Welcome to today's session where we do some backend stuff, SmallRye.
As always, we want to do Quarkus. We want to continue our SmallRye fault tolerance series. And today's topic will be the Bulkhead operation. Or annotation better. So if we go to the code, we want to, if you remember from our previous sessions, we have our very unreliable cookie service. And today we want to extend this and add a cookie delivery service. Unfortunately, our cookie delivery service has a limit of 2 drivers. So we will need to to handle this limited resource. Keep in mind, this is a very artificial example, and you wouldn't do it like that in real world, but I need to make a small example for you guys. So what we will do, we first create a new resource. This is our cookie delivery resource. On some path, cookies delivery. So what we want to do is we want to get some cookies delivered. Cookie delivery. So this is our REST method. We don't add another path. We just add this is a get method. And that's it for now. We want to get the delivery. So I will so we have to be able to log stuff. We first need a logger. Logger, get logger for our cookie service or resource rather. Okay. In our case, we want to limit our amount of drivers we have. So I do a very basic implementation here. I have I have 2 atomic longs. Basically, one is just a counter. So we have something to log to see which delivery we are handling. And the other one is the amount of available drivers we have. So whenever we get a new cookie delivery request, we first get a delivery ID, which is just delivery counter increment and get. So we atomically increment and get it. The atomic part is important because we can have multiple requests in parallel. So
that we don't end up having the same ID.
Yeah. And as I said, this is not something you would want to do in practice. There you would have a database and whatever.
Yeah, that's just for the example.
Just for demonstration's sake. And then we check if a driver is available by doing like available drivers, decrement and get, and if available is now smaller than 0, then there was none available. We better put the driver back that we took that wasn't there. And we say there is no driver left. And we throw not found exception because there was no driver. In the other case, we had a driver, so we can do some logging just for fun's sake, starting delivery with the delivery ID. This take a while, so delivery is not something that happens instantly. So we just delay here a bit. For example, we wait like 5 seconds. That's the time it takes our delivery. And only in the end we finish it and delivery is finished. Okay, and we put back our driver. Increment. and return new cookie for year. Okay, that's our very basic example. And we want to have a look how this would work. So what I'm gonna do, I'm gonna open my browser. It's a GET request, so it's a simple thing. Cookies delivery, and we can make this call. Can have a look at the log. Starting delivery 1. This might take a while. Delivery 1 is finished, and here's our new cookie. So what happens if I do this a couple of times in parallel? 1, 2, error. So what happened? We started delivery 2 and 3, and no driver left. We could add the ID for delivery ID. So you see, there we have a problem. And what we can do to avoid this, we can use the bulkhead annotation. A bulkhead is just something similar to a semaphore or so, where you can specify a limit of how many concurrent requests you want to allow.
Okay.
So in practice, this could maybe be a call to a service that maybe you have an external or third-party service that cannot handle more than a certain amount of traffic. So you could use such a bulkhead, for example, to throttle it a bit on your side. The bulkhead annotation, it has a value and a waiting task queue. So the value is the amount of concurrent requests you want to allow. And if a request is not, if it's not possible to handle this request at a moment, then it's put into a queue.
Okay.
Keep in mind, this is an in-memory queue. So if your server dies, this queue will be lost. But you can put stuff in that queue automatically, and it will then be executed later. So if we add this here, we set our value to 2. So we allow only 2 concurrent requests. We give this a try.
So what would happen if the queue is full then? Then you
get the exception.
Oh, new follower, Aconsis Media.
Nice. Who could that be?
I don't know.
Thank you so much.
Some creative naming.
Yeah, for the random follow. So we can again start 1, 2, and 3. And you see the third doesn't crash.
So you don't get an error because the third one is queued.
In the queue. And you saw here the first 2 had already finished. And now the third one is finished. And what we see here is we started delivery 1, we started delivery 2, and no start of delivery 3. Only after delivery 1 is finished, we start with the third.
Okay, nice.
And then the second finishes and the third finishes. But if we now would add, like, I press a lot of F5 to fill up the queue, then there will be rejected by the bulkhead. It was just too much. We overflow the queue. In that case, again, we could use the fallback annotation and make fallback. It was fallback build fallback method. Okay. So I can make a fallback method here. And it has to have the same signature, so it must also be suspend function if your original method was suspend function. And here we just return sorry out of business. It's a bit unfortunate that you reference it here with a string, and so IntelliJ does not directly know this is referenced and so on, so it looks unused,
Okay.
but it is actually used. And if we now do this, we should see, sorry, out of business.
Okay.
But at least we can return this immediately and yeah, handle it differently.
So it tries first the queuing stuff.
Yeah.
And when that is full or out of capacity, then it will go to the fallback.
You also see here we are still processing the queue, delivery 5 and 6 and so on. Yeah.
Okay, so in a real world example, you could reload or do the request again when you get out of service.
Yeah.
And hopefully the queue is then has space in it, and then your request can be handled. Otherwise, you again get a fallback error.
Yeah. I mean, also when you have the fallbacks, best use of it is if you can really provide a reasonable fallback. For example, if you have you want to show the products of your shop, then you could provide like a default list instead of a machine learning optimized custom list, because if like you have 2 GPUs on your server, so you want to limit the amount of machine learning tasks you can run at the same time. And if there's just too much load, then you have to provide some other fallback, maybe go back to a standard static list.
Okay.
And then your customer gets a bit of a worse experience, but he might not even notice because
but at least an experience.
He gets an experience, and you can still serve him.
Okay.
Yeah.
Okay, nice.
Okay. So that's the bulkhead operation, or annotation with SmallRye fault tolerance.